There is a moment in December 1986 that very few people alive today know about. A cargo plane descended through a gray winter sky over northwestern China, its engines cutting through air so dry it cracked lips and burned lungs. When the loading ramp finally touched the frozen ground of the Yungar Basin, 11 horses stepped out into a landscape so hostile, so thoroughly dead, that the scientists watching from a distance already had one hand on their pens, ready to write the obituary. Nobody seriously expected these animals to last a single winter. What happened over the next 4 decades instead would force some of the world's most respected ecologists to rethink nearly everything they believed about how broken land heals, and who does the healing. To understand why anyone sent horses into this particular desert, you first have to understand what the Yungar Basin had become by the mid-1980s. This was not simply a remote wasteland that China had decided to ignore. It was an active emergency, a spreading wound that was reaching out from the country's northwest and quietly strangling land and people hundreds of miles away. For thousands of years, the steppes of Xinjiang province had sustained a remarkable web of life. Grasses grew deep-rooted and thick. Wildlife moved in seasonal rhythms across the plains. The soil, though arid, held enough moisture and biological activity to anchor the landscape in place. What kept all of this functioning was a system of natural pressures and disturbances, grazing, trampling, seed spreading, carried out by the animals that had evolved alongside the land itself. Then those animals vanished. The wild horses that had roamed these steppes were gone by 1969, pushed to extinction in the wild by a combination of hunting pressure, competition with livestock, and the disruption of traditional grazing territories. The last confirmed wild sighting was recorded by a Soviet survey team, a few hoof impressions in dried mud, a tuft of coarse mane hair on a thorn bush. After that, silence. What followed stunned the scientists who were paying attention. Without large grazing animals working the ground, the topsoil began to seal over. Rain still fell, 4 to 6 inches a year, but instead of penetrating the earth, it sheeted off the hardening crust and evaporated within hours. Seeds could not break through the surface to germinate. The soil's biological complexity, the invisible community of bacteria, fungi, and microorganisms that made it living rather than merely mineral, began to collapse. By the mid-1970s, researchers comparing soil samples from the Yungar Basin to reference soils from functioning ecosystems described the difference in stark terms. It was closer to compressed dust than to earth. The desert started to move. Satellite data from the early 1980s revealed that the Gurbentungut Desert, the Great Sand Sea at the heart of the Yungar Basin, was expanding at a rate that swallowed thousands of square kilometers per decade. Villages that had existed for generations were being buried. Farmland that fed entire communities was disappearing under drifting sand. Roads and rail lines had to be rerouted, sometimes more than once, as the desert kept advancing. But the truly alarming development was what was happening 1,000 miles to the east. Beijing, China's capital, was being hit by dust storms of a severity and frequency that public health officials had never recorded before. In the spring of 1983, a single 3-day storm deposited tens of thousands of tons of Xinjiang topsoil across the capital. Hospitals reported hundreds of respiratory emergencies. Schools closed. The city turned a sickly yellow-brown, and residents who went outside came home tasting the Northwest on their tongues. China was not losing a distant province. It was watching its own heartland slowly suffocate under dust from a land it had already hollowed out. The government's response was not passive. Beginning in 1978, China launched one of the most ambitious land restoration projects in human history, the 3 North Shelter Belt, popularly nicknamed the Green Great Wall. The plan was to plant a continuous belt of trees more than 4,000 kilometers long across the northern frontier, creating a biological barrier that would stop the desert's advance. Billions of trees were planted. Billions of dollars were committed. The scale was genuinely staggering. And in many places, it quietly made things worse. The trees selected for mass planting, fast-growing, drought-resistant species like poplar and elm, needed more water than the land could reliably supply. As their root systems expanded, they began drawing down water tables that had been stable for centuries. Wells ran dry. The very groundwater that local communities depended on for drinking and agriculture began dropping at rates that alarmed hydrologists. In some regions, the water table fell more than 10 meters in a decade. Entire villages had to be abandoned. The trees, planted in neat monoculture rows for efficiency, also created none of the ecological complexity that a real forest provides. No understory, no diverse root systems, no habitat for the animals that would have helped regulate the system naturally. Other interventions followed. Engineers tried spreading straw grids across open sand to stabilize the surface. Researchers experimented with drought-tolerant shrubs. Chemical binders were tested to fix the topsoil in place. Each approach offered limited, localized results. None addressed what was actually wrong with the land. By 1985, the situation had become a crisis that China's scientific and government establishments could no longer manage with the tools they had. Agricultural output in Xinjiang province had declined sharply. The desert was not slowing, and the computer models projecting forward from current trends were producing numbers that nobody in a position of authority wanted to read aloud. It was into this atmosphere of exhausted desperation that a Chinese conservationist named Yang Zhihua walked into a government meeting and proposed something that, by the standards of the moment, sounded almost delusional. Stop trying to engineer the desert into submission. Bring back the animal that had shaped this land for 10,000 years. Bring back the Przewalski's horse. The Przewalski's horse, known in Chinese as Pushiyema, and called Taki by the Mongolian people who had lived alongside them for centuries, is not simply an old breed of domestic horse that went feral. It is a genuinely distinct species, the only horse lineage on Earth that has never been domesticated at any point in its history. Its genome carries 66 chromosomes, compared to 64 in every domestic horse alive. Its body is compact and heavily muscled, built for endurance rather than speed. Its mane stands straight up in a stiff ridge rather than falling to one side. Its coat changes dramatically with the seasons, pale tan in summer, thickening to a dense, insulating brown in winter. For tens of thousands of years, these animals had been fundamental architects of the Central Asian steppe. Their grazing patterns, their movement across the landscape, their physical interaction with the soil, all of it was woven into how the ecosystem functioned. Cave paintings from across Eurasia, some dating back 40,000 years, show these horses in remarkable detail, suggesting how deeply they registered in the awareness of the humans who shared the land with them. By 1985, every single Przewalski's horse left on Earth was living in a zoo. The species had come astonishingly close to disappearing entirely. Populations in the wild had been hunted and displaced through the late 19th and early 20th centuries. The last confirmed sighting of a wild individual was in 1969 in Mongolia. The captive population, descended from a small number of individuals captured by European collectors around the turn of the century, had been decimated further by the Second World War. At one point, the entire species consisted of fewer than 40 animals in two facilities, the Munich Zoo and the Prague Zoo. The genetic bottleneck was severe. Every Przewalski's horse alive today carries the imprint of that near extinction in its cells. That there were any horses left to send to China at all in 1986 was itself a story of last-minute survival. Yang's proposal called for importing horses from breeding programs in West Germany and the United States, establishing an acclimatization center near the town of Jimsar in Xinjiang, and then, after a period of conditioning, releasing the animals into the Kalamli Nature Reserve, 4,000 square kilometers of some of the most forbidding terrain in Asia. No supplemental feeding. No veterinary intervention for minor ailments. No human management of their social structures or movement. The horses would either remember how to be wild, or they would not. The skepticism in the room was intense. These animals had spent 3 and 4 generations behind wire fences, fed by humans, watered by humans, protected from every pressure that natural selection would have applied. They had never navigated a landscape. They had never read the weather. They had never heard a wolf. What exactly was going to happen when animals with no survival experience met a desert that had already defeated every human attempt at restoration? Yang's answer was essentially, watch. The horses arrived at Jimsar and immediately looked exactly as wrong for the environment as their critics had predicted. They stood in the freezing wind and did very little. They drifted in small circles near the fencing that used to define their world. They kept looking, the research team noted, in the direction of the buildings, as though waiting for the routines of captivity to resume. The first winter arrived fast and savage. Temperatures dropped to -40 degrees Celsius. Winds cut across the open basin without interruption. Snow buried the sparse vegetation under layers of powder. The horses that had spent their lives in heated barns were now fully exposed to conditions that would test even animals born wild. 7 animals developed frostbite. 2 pregnant mares lost their foals to the cold. The international press was already composing the narrative, a well-intentioned but naive experiment, the inevitable failure of romanticizing nature. Yang's team, watching through binoculars from a monitoring station, enforced upon themselves the discipline of not intervening, because the entire scientific premise rested on finding out what these animals could do without human help. What they saw instead, over the weeks that followed, was something none of them had a framework to explain. The stallions began using their hooves to break through the ice crust on frozen pools and streams to reach the water beneath, a behavior that had never been observed in any captive Przewalski's horse, anywhere, in the entire history of keeping them. The mares organized themselves into formation around the youngest animals during the worst storms, rotating positions so that no single horse bore the full force of the wind for too long. Individuals began pawing through snow with a specific sweeping technique to uncover dormant grass that domestic horses would never have searched for. Nobody taught them any of this. No previous generation in living memory had demonstrated it. It surfaced, behavior by behavior, as though the desert itself were reactivating something the zoos had only managed to suppress rather than erase. The research team's field notes from that winter read less like scientific records and more like a log of consecutive astonishments. By spring, 11 horses had survived. What happened to the soil beneath those horses in the months that followed was the part of the story that eventually traveled far beyond the conservation community and into economic and policy circles worldwide. Each horse weighed between 270 and 360 kilograms. Moving at a walk or trot, their hooves struck the ground with considerable force, enough to fracture the biological crust that had sealed the basin's surface and prevented water infiltration for nearly 2 decades. But unlike mechanical disruption, the horses were selective. They naturally avoided fragile seedlings and new growth, concentrating their impact on bare, compacted ground. The result was what ecologists later described as a mosaic of disturbed and undisturbed patches, each type of patch supporting different plants, different insects, different microclimates. The horses also moved constantly. GPS tracking would eventually reveal that a typical Przewalski's horse covers 15 kilometers a day, not in straight lines but in complex, overlapping patterns that ensure no single patch of land is overgrazed while also ensuring that no patch is left entirely untouched. This movement distributed the animal's ecological impact across vast areas. Then there was the manure. Analysis of Przewalski's horse dung revealed something that researchers initially found difficult to believe. It contained viable seeds for more than 20 native plant species, and the passage through the horse's digestive system significantly improved germination rates compared to seeds that had never been consumed. 1 gram of dung contained multiple viable seedlings. Across the 15 kilometers a horse traveled each day, it was continuously planting, distributing seeds into freshly disturbed soil, pre-fertilized and ready to receive them. Within the first year, moisture retention in the soil of grazed areas improved measurably. Within 2 years, nitrogen levels, which had crashed toward baseline desert values, had begun climbing back toward figures associated with functional grasslands. By the 3rd year, botanists were documenting the return of plant species that had not been recorded in the Yungar Basin for nearly 20 years. Their seeds had been in the soil the entire time, waiting for conditions that would allow germination. The horses had created those conditions. Then the rest of the food web began reassembling itself. Dung beetles recolonized the area, accelerating the decomposition and nutrient cycling that the manure had initiated. Insect diversity increased, pulling in migratory and resident birds that hadn't been recorded in the region in years. Small mammals followed, and the predators, foxes, raptors, eventually wolves, arrived to complete the chain. The basin had not been dead. It had been locked, and the horses had opened it. In August 2001, with the Jimsar herd grown to several dozen animals over 15 years of careful acclimatization, Yang's team made the decision that would define the project's legacy. 27 horses were selected for full release into the Ecology Nature Reserve. No enclosures, no supplemental feeding, no intervention short of a genuine population-level emergency. Among the 27 was a stallion named Hong, a name meaning red in Mandarin, given for the warm reddish tint in his coat. He had been born in the Jimsar facility, had never been fully wild, and was now walking out into open desert for the first time in his life, leading a family group of his own. For 7 days, the GPS data showed what the team had expected. The horses stayed close to the release point, moving in cautious circles, grazing nervously on the immediate surroundings. Then, on the morning of the 8th day, Hong's signal began moving north. Not drifting, moving. In a direct line, at a sustained pace, into empty desert. His family group followed. The team scrambled to interpret what they were seeing on their tracking screens. The horses covered 5 kilometers, then 10, then 20. There was no mapped water source in that direction. There was no visible reason for the movement. By the time the signal stopped, Hong had led his herd 30 kilometers into terrain that the project's maps listed as barren. When the researchers drove out the following morning, they found a spring-fed pool, half-frozen, tucked behind a low ridge, completely invisible from the release site, absent from every survey the project had conducted. Hong was standing beside it, calm and unhurried, as though he had known it was there all along. He had been born in captivity. His parents had been born in captivity. His grandparents had been born in captivity. No horse in his living lineage had navigated this landscape. And yet some combination of sensory perception, geological pattern recognition, or ancestral memory embedded in ways that science still does not fully understand, had guided him across 30 kilometers of desert to water that humans with maps and instruments had missed entirely. The researchers who had spent years feeding Hong by hand stood at the edge of that pool and felt, by several accounts, the particular kind of silence that arrives when something you were certain you understood turns out to be far more complex than you imagined. By 2010, the project had generated enough longitudinal data for ecological economists to attempt something that had not been done before: a full accounting of the measurable value that a single Przewalski's horse contributes to a recovering landscape each year. The numbers they produced were not what anyone in the room expected. Soil restoration value, calculated from the improved infiltration, aeration, and biological activity attributable to horse activity, approximately $12,000 per animal per year. Seed dispersal services, based on the documented range and germination success of seeds carried in horse dung, around $8,000. Water retention improvements, measured against the cost of engineering equivalent infiltration capacity, $15,000. Carbon sequestration through the grassland recovery the horses enabled, $7,000. Biodiversity support, reflecting the cascade of species recoveries traceable to horse reintroduction, $5,000. Total, roughly $47,000 of ecological service value per horse, per year. By 2023, the original 11 animals had grown to more than 500 individuals in China's Ecology Reserve. At The Economist's figures, that population was generating over $25 million in ecological value annually, and that was the conservative estimate, before tourism revenue, research value, or carbon credit markets were factored in. The desert that had expanded for decades was, in the zones where the horses roamed, beginning to retreat. The water table that had dropped for 30 years stabilized in 2003. Then it began, slowly, to rise. Satellite imagery showed green expanding outward from the horses' core territories in patterns that matched no planting program. No irrigation scheme, no human design, because they weren't any of those things. They were the signature of an ecosystem resuming a conversation with itself that had been interrupted for 3 decades. China is now expanding the Ecology Reserve and working toward an official goal of 2,000 wild Przewalski's horses by 2040. Mongolia's Harshest National Park, which began its own reintroduction program in 1992, had passed 400 horses by 2023 with the surrounding steppe showing recovery patterns nearly identical to Xinjiang's. Kazakhstan launched a new reintroduction initiative in 2024. Across Central Asia, an animal that existed nowhere in the wild in 1985 now numbers nearly 1,000 individuals roaming free. Every program has confirmed the same underlying principle. You cannot restore a complex ecosystem from the top down using blueprints drawn by humans who were not present for the 10,000 years it took to build the thing in the first place. The architecture is too intricate, the feedback loops too numerous, the variables too entangled. What you can do, what China did, slowly and at great risk, is reintroduce the species that the ecosystem built itself around, and then have the discipline to step back. The horses never needed a management plan. They needed the fences taken down. There is something both humbling and clarifying about that conclusion. We have spent the modern era treating ecological restoration as an engineering problem, a question of what we can add, plant, spray, or construct to reverse damage that took decades to accumulate. The Yungar Basin suggests a different question. What did we remove that was doing the work we are now trying to replicate with machines and chemicals and billions of dollars? The bison that once shaped the prairie grasslands of North America. The wolves whose presence restructured the behavior of elk herds and, through that behavioral change, allowed riverbanks to revegetate and streams to stabilize. The elephants that open forest canopies, dig water holes that dozens of other species depend on, and disperse seeds across distances no other animal can match. Every continent has its own version of this story, a keystone species removed, a cascade of consequences that no one fully anticipated, and a growing body of evidence that no human substitute has yet come close to replacing what was lost. The 11 horses that stepped off a cargo plane onto a frozen desert in 1986 were not, in the end, a conservation story about saving an endangered species. They were a demonstration, running in real time over 4 decades, of what evolutionary engineering actually looks like, and how much we have yet to learn from it. The desert retreated. The water returned. The land remembered what it was. The horses had simply remembered first.